today we are working on lesson 7.2, and this section is about finding the volume of some different shapes, some different solids. And we're going to learn the disk method, it's called. Okay? And what this is about, I like how the book talks about it. I have the text right here. We have already learned that area is one of the many applications of the integral. We use the integral, we integrate to find area. Another important application is its use in finding volume of three-dimensional figures, three-dimensional solids. So in this section, that's what we're going to be studying. We're going to be studying finding the volume of a three-dimensional solid. And they talk about cross-sections. You'll see that in a minute. Solids of revolution are commonly used in engineering and manufacturing. Some examples are axles, funnels, pills, bottles, and pistons, as shown here, all these different figures here. Okay, so they're talking about today to use integration so we can find the volume of different shapes like this. So I like, again, the pictures that the book has on some of these things. They can draw it a little better than I can. So they're talking about, think about if you just had a rectangle, just a simple rectangle. If you were going to revolve that and rotate it around the x-axis, for example, then it would look like a disc. If you rotated that rectangle around, and they're going to put little arrows in the book to show rotation. If you rotated that around, it would make like a disc. And you can see that's kind of a circular shape. The volume of that disc is pi r squared, because it's circular in shape, pi r squared times the width. So that's where our concept today comes in, to find the volume of these discs, the volume of these different shapes. You were thinking of the area times the width. That gives you volume, like the area of the base times the width. So it's pi r squared times the width. Well, that's just one rectangle. In these shapes, if I keep showing you some of these pictures out of the book, it's helpful. That's just one little rectangle. But if you have like a whole blue area like there that you're going to rotate around, you can make many rectangles and then add up all those areas of all those. See, like n number of discs, like a certain amount of discs. And if you integrate, it's like adding up all those discs when you integrate. It's like the width part is like adding up all these rectangles. So that's where our formula is going to come from. We're going to be finding the volume of these discs by, basically it's pi r squared times the width. But the width is like the integrating part, like I was trying to explain. So really, here's our formulas. So in a nutshell, it's volume equals pi, integral from a to b. This capital R stands for like radius squared dx. That's if you use this formula if you're rotating around a horizontal axis, like in this picture here. Like if you're rotating like around the x-axis, for example, like a horizontal line. Use this formula. If you're rotating around a vertical line, like the y-axis, you're rotating around some vertical line, then the formula is basically the same, but it's with respect to y. Pi, volume, to find volume, it's going to be pi, an integral from point C to D. They just use C to D instead of A to B this time, just so you notice it's y values this time, C to D on the y-axis. And then you're going to use the radius. It's like how big this rectangle is, this yellow rectangle. It's this rectangle. That's your radius. And you square that, and then it's dy. So these are our basic formulas. that we're going to use. And let's just try a problem so you can see how this works. Alright, so this volume disk method, like I showed you in the book, if you're working on a horizontal axis of revolution, like if you're revolving around a horizontal line, then you use this formula. Volume equals pi integral a to b, radius squared dx. But if your equation tells you to rotate around a vertical line like the y-axis, vertical axis of revolution, then our formula is going to be v equals pi integral from c to d. Those will be values on the y-axis, like I was saying. And this one will, it's still radius, but it's like a, we make our rectangle like, you'll see how we draw it. It's a formula with y variables in it, and then dy. So we'll have to decide which of these formulas we're going to use on different problems. Okay, so we'll just go through one so you can kind of see how this works. We'll do example 1. This example is right from the textbook. So I know a lot of times you guys just go ahead and do your assignment, but you could, like when you go to WebAssign and look up the assignments, you can look at the actual text too sometimes and look at what examples are in your textbook, just like I was showing the textbook under the camera. You guys can view your textbook online on webassign.net. Okay, so here is a formula, and it says find the volume of the solid formed by revolving this region around the x-axis. So it'll tell you like what to revolve your problem around. Revolve about the x-axis. So we want to use Desmos or some kind of graphing tool so that you can graph this function and just do it kind of quickly when you do your assignments. You know, use Desmos or a graphing calculator. I'll just graph it really quickly for you. If you grab your graphing calculator or use Desmos, it looks some kind of function like this. And it'll tell you, again, in the book what you're going to revolve around. And it actually also says in the book on this one that you're going to be just looking at this function from 0 to pi. It gives you like an interval on this one also. So it tells you go from 0 to pi. So that's what I have graphed here for you. Okay, 0 to pi. All right, so it says revolve about the x-axis. The x-axis is this line. That's a horizontal line. So I want to use this formula up here. We're going to do the horizontal one. Horizontal, you know, you can draw yourself a picture. Horizontal is like side to side. When you're revolving around a horizontal line like the x-axis, you're going to use this formula. So it's going to be v equals pi. We're doing an integral from a to b. A to b are numbers on the x-axis because we're integrating with respect to x. So see, we're integrating from like 0 to pi. It's going to be pretty simple to figure out. Okay, now the formula says to do a radius squared and then dx. Well, what's our radius? They're telling us to revolve this drawing right here. I'll kind of shade it in a little bit. They're telling us to revolve that around the x-axis. So if I revolve it, I'm like turning it around. It'll make like a 3D shape. Like more like that. Like a 3D shape. Kind of like a football looking thing. Okay? So when when you're revolving around the horizontal axis, they actually, a lot of times it's helpful, they have you draw like a rectangle in there. I'll draw it in red. The book had them drawn in yellow. But they're trying to get you to see, it's like rectangular sections that you're revolving around the x-axis. So you draw like a little red rectangle. And how tall that is from the center, like the center line 0, it's right on the x-axis, so that's at 0. And how tall that is your radius. And how tall that is it goes up to that line, this curve, which is the square root of sine x. So the radius is like square root of sine x minus 0. That's how big the radius is. From here to here, from point A to B, like the height of it is just square root of sine x. That's your radius. It's going to be square root of sine x. Radius squared. The formula says to square the radius, dx. Okay, so now if I square that, if you now get rid of the radical when you square it. Okay, now I'm going to have to integrate it. If you integrate sine, it's actually negative cosine. So now I have to evaluate that from 0 to pi. Don't forget this pi out front. Just keep bringing it along. Just keep bringing it down. So I'm going to have to plug in pi into here, like negative cosine of pi minus negative cosine of 0. So you're going to have to figure that values out with your calculator. So if you type this in your calculator, negative cosine of pi. Make sure your calculator's in radians, which I need to do. So let's see, negative cosine of pi. That's 1 minus negative cosine of 0. Negative cosine of 0 is negative 1. So it's 1 minus negative 1. That's really 1 plus 1, which is 2. And then don't forget to times it by the pi out here. So your final answer should be 2 pi. Okay, now we'll take a look at another one. And this is example 3 from your book. So if you, like I was saying, if you ever want to actually look at your textbook, you can just go to webassign.net, and instead of going to the problems that you do every day, look at some of the book section. You can look at some of these examples yourself. Okay, so now this one has another, like a new equations again. So we have y equals square root of x and y equals x squared. It says find the volume of the solid formed by revolving this region bounded by these graphs about the x-axis. So again, it tells you to revolve around or about the x-axis. So it says x-axis again, so I'm going to still use this way. If it would say y-axis, then I'll have to do the other way. Okay, so it says revolve about the x-axis this time. Okay, again, a picture is very helpful. So if you use the Desmos or graphing calculator, make a sketch of these things, it will really help. This one, I'm just going to graph it really quick. Like I said, you can use Desmos and look at them. It's like two curves that intersect like this. And it's helpful to know where they intersect. Like, how would you find out where these intersect? Well, on a graphing calculator you can do that, or on Desmos. If I'm on a graphing calculator, I can show you. I would type these in, like y equals square root of x. I'll type it in and do it quick. And then if I go down, this one's x squared. Okay, so I can graph these two things. Okay, and you might want to zoom in a little. It's kind of hard to see them. It's very small. So zoom in, I'll do zoom 2. Zoom it in even more so you can see it. There we go, there's a little better. See, it's just this little corner like I was trying to draw on my page here. Where do these intersect? Well, if you use your arrow buttons on your calculator, you can kind of move your cursor. You have to hit second. There's a trace button, but if you hit second and the trace button, it says calculate, and you can calculate intersection points, number 5. You just hit 5, and you move your cursor with the arrows up to that spot where you think they're crossing, and then just hit enter, and then hit enter again, just kind of be close to that spot where you think they intersect. Hit enter again, hit enter a third time, then it tells you intersection 1, 1. That point where they intersect is 1, 1. Desmos is very handy too, and it tells you where they intersect. You can just click on the points on Desmos. Another way to find where they intersect is equal these equations to each other and solve, and you can get it also. You can do it algebraically. Okay, so we're looking at this section, this picture. It says to revolve it around this x-axis line again. So if you turn that and spin it around, it's like you got to think of rotating this thing. I mean, I'll try to draw it. I'm not the best artist, but it would like be turning this thing around. Like I can do kind of like it'd be kind of like a funnel in the middle, like a hollow spot in the middle, and it'd be looking like that. It's rotating around. The book has a nice picture of it. I can show you. The book has a nice picture of it here. If you took that and rotated around, see, it looks like this, and it is hollowed out in the middle. There'd be a spot in the middle like a funnel, hollowed out in the middle. Okay, so if it's hollowed out in the middle, there's like empty space that you're going to have to get rid of, like subtract out, like take out. So they call this one more of a washer method. It really is the same as this, but it's going to be like kind of 2 steps. Like it's pi r squared still, but then you have to minus and subtract like where the middle part is like a hole. So they call it the washer method, which really is the same as what we did up above, but it goes volume again equals pi integral from a to b, and then see, like if the whole shape was colored in, it would have been easier if it was a solid shape like this one, but like I'm saying, there's a hole in there. So it's like you need the outer radius, like big R squared, and then you have to subtract and take away the hollow part, like cut that out. You don't want the volume of the inside. The inside's hollow. So you minus, they've just put little r, like a small radius, like the inner part, get rid of that. Minus little r of x squared. So they call it a washer method. It's the same as disk method, you just have to remember to take out the hollow part. Alright, so let's get this one set up. Alright, so we got volume equals pi. Okay, we're integrating with respect to x, so we want to know the x-axis. We're going from where to where on the x-axis. We're going from 0 over to 1. So you integrate from 0 to 1. Okay, this big R. It's like going to the outer edge and then subtracting away this part, this middle part that's hollow. So it really just ends up being a rectangle just between there to there. It's like the whole thing minus this hollow part, so then it's really just up here. You know what I'm saying? Hopefully you get what I'm saying. So it's like the top, what's the radius from the middle all the way to the top line? That top curve was the square root of x. So the outer radius is square root of x. Like this top curve is square root of x. And then this inner curve is x squared. So it's just the outer radius minus the inner radius squared. Outer radius is the square root of x squared. The inner part that's hollow that we're trying to like subtract away, get rid of it, is x squared quantity squared. That's how you set it up. Like subtract the outer radius minus the inner one. It's kind of like the top curve minus the bottom curve. Each thing squared though, you gotta remember to square it. So if you square this, you just get x. If you square this one, you get x to the 4th. Now you can integrate it. From 0 to 1, bring along that pi symbol, don't forget that. And now, the bell's ringing, sorry, it'll quit in a second. Okay, now you can plug in the numbers, you know, it's like f of 1, plug in 1, so it'd be 1/2 minus 1/5. If you plug in 0, you get 0, so it'd be this answer minus 0. Don't have to really write minus 0. Alright, so 1/2 minus 1/5. Let's see if I do that. It would be 3/10. So it'd be 3 pi over 10. It'd be after times by pi. There's the answer for that one. Okay, so both of these I've done were with respect to x. I'll do one more with the y, you know, do one this way so you can try see one of those, and then you'll have time to work on your assignment. Okay, this is another problem when I do a lot of the examples in class. They are from the book. This is example 4 in the book from lesson 7.2, and I've drawn it for you here. I have all the equations. So it's an area that's bounded by all those equations. X squared plus 1 is here, y equals 0, x equals 0, x equals 1. So it's this area, this region in here. And it says to revolve around the y-axis this time. Revolve around the y-axis. So if you do that, again, you can kind of think three-dimensional. It would make it come over to here. It would be like 3D, like revolved, like turned around here. It'd make it like that, instead of lightly shade it. So it'd have like a hole at the top, but you might notice that it's solid all down here. It's all solid down here. It just has this bowl at the top kind of carved out. So that's kind of important in this one to see that it is all solid from 0 to 1 on the y-axis. It's all solid down here. It's all solid. But then up here, like your rectangle is like here, where it's hollow in the middle. Yeah, hollow in the middle up there. So this one you actually have to do in 2 parts. This time it's revolving around the y-axis, which is a vertical axis of revolution. So it's going to be a dy problem. So these integrals are y values. Like you're going to go from these points are y values. So this one is a 2-step process, okay? So our formula is pi. And like I'm saying, it's all solid down here, nothing like cut out. So you can just go from like integrate from 0 to 1 and do an integral and try to work on this bottom part of it. And then over here, try to leave room. And then have another integral over here from 1 to 2. And try to deal with this hollowed out, cut out part on this one. So it's going to be a 2-step problem. This is a tough one. Okay, so again, referring to the formula, it's pi r squared dy. So this is all solid down here. What's the radius, or like how tall is that red rectangle I made? What's that radius? That radius is just 1. That radius is just 1. Radius squared. Like really, like 1 minus 0 is 1. Radius squared, 1 squared, dy. So this part's the easy part of the problem. Top part is the hard part. When you integrate from 1 to 2, okay, what's the radius? We talked about this on the last problem. You have to like go to the outer edge. It's like the outer radius squared minus the inner radius squared. It's like big R of y squared minus little r of y squared dy. That's the formula. That's what, when you do when it's a hollowed out part, you have to have like a big radius and then subtract away this hollowed out part, like that bowl in the middle that's hollow. So the outer radius is a distance of 1. Like this, from the center where you're revolving around all the way out to here is 1. So it'd be 1 squared minus, what's the inner radius? The inner radius goes to this curve right here. Like from the center line is 0 over to here, that's x squared plus 1 minus 0. So it's just x squared plus 1 quantity squared dy. Oh shoot, I just messed up. Okay, this is a dy. And see, that's why it's really important to know if you're doing dx or dy. Okay, this is dy. I can't have this having an x in it here. That's why I was like, oh shoot, see, I just realized it. And you're going to realize that when you do assignments sometime, but I'm going to fix it. I have to have this formula here with a y, not an x. So you have to work on these problems sometimes. I'm actually glad I made that mistake and then caught myself to explain that to you. It helps you guys to learn. See, this said y equals x squared plus 1. You have to solve that problem for x. So you have to subtract 1, so it's y minus 1 equals x squared. Then you have to take the square root. See, it's the square root of y minus 1, that equals x. So instead of having this is wrong, because I have to have my formula with y's in it. So I have to get rid of this, take this out, and put in, I'll just rewrite it, y minus 1. That's in the square root quantity squared. It's actually really good I made that mistake so you guys can see that. You'll notice that the variables have to match. Okay, so we got pi, integral from 0 to 1. 1 squared is just 1 dy. Okay, so it's 2 integrals that we'll have to figure out. So if you integrate 1, that's just y. Evaluate it from 0 to 1. So plug in a 1, you just get 1. So this first part's just like 1 pi. Okay, I got the first part, it's just pi. That's simple. Second part's a little more challenging. Okay, so 1 squared is just 1. If you square this, it gets rid of the square root. So it's 1 minus y minus 1. Watch out for all these negatives. You have to distribute the negative. So it's 1 minus y plus 1. So it's really 2 minus y. Integrating that. Okay, so if I integrate a 2, it's going to be 2y. If I integrate this, it's y squared over 2. Then try to evaluate it from 1 to 2. Don't forget to bring the pi down and keep working it out. Okay, so I'll plug in 2. Copy what I got so far. Okay, plug in a 2. That would give me 4. Let's see, 2 squared is 4. 4 divided by 2. So I'd have 4 minus 2 minus, now I plug in a 1, and I get 2 minus a half. I can figure all that out, and then we'll get our answer. Okay, so let me get a calculator. Okay, 2 minus a half, that's 1 and a half. So 2 minus 1 and a half is a half. So pi plus pi over 2, that'd be 3 pi over 2. There's my answer, 3 pi over 2. Okay, so again, I am really glad that I made that mistake at the beginning, because I started putting it in, I'm like, wait, oh, I messed up. Yeah, because that's an x, and we're integrating with respect to y. We're rotating around the y-axis, so that formula can't be the right formula. You have to solve for x. So you can plug in some formula with respect to y and then do it. So hopefully that helps you guys out. That was a tricky one because it's two parts. Two steps because part of this was solid and part of this had a hollow part cut out. So we had to do it two integrals. Okay, so go ahead and go to Canvas, look up your assignment for 7.2 and work on that, and I'll help you out during class time.